This worksheet is exactly like the one you did a couple days ago, but when you deal with polynomial functions, some of the shortcuts you've developed for quadratics no longer work. For instance, let's say, hey, no more mooing. Amy's over here mooing. That will forever be on the internet. So, let's say that I had a cubic equation, and it hit here, here, and there. Okay? On your calculator, it's really hard to see, but if one of the roots is -4 and one of the roots is -1, first of all, would that be considered the maximum? No. What is the maximum? Infinity. But we do call this a relative maximum. Because if you're near that point, it is the highest point that's close to it. No, so what you'll do on your calculator is to find this, you'll still do a left bound and a right bound, but is that actually the maximum? No, the maximum would be infinity. Yeah. Hey, no more mooing. So that brings up a good point. What did I miss? Oh, that's fine. That's the language I spoke without my tonsils for the first day. So, does an x to the third have a max or a min? You can either write no or infinity or negative infinity. I don't care which one you write. But what about an x to the fourth? Could it have a max or min? Yes, one or the other, right? That would have a max or a min, and that would have a max. What about x to the fifth? No. What about x to the sixth? One or the other, depending. An x to the sixth would have a minimum. A negative x to the sixth would have a max. But the other thing that's tricky, if you look at this, that portion looks kind of like a quadratic, but it is not symmetric. Okay? It's going to lean either to the left or to the right, and it usually leans toward the longer side. So if I went over here at negative 2.5, that would actually miss the maximum by a little bit. I had to cheat, but so that relative max is going to lean a little to the left. And likewise, this relative min is going to lean to the right. So when we took that test on the bonus question, on something like this, you would have said, oh, if that's a root and that's a root, then negative 2.5 would be the maximum, and then you just plug negative 2.5 in, and you got a point that was close to the max, but it wasn't actually the max. Okay, and that's really common. Okay, if you have an x to the fourth graph, so if you have something like this, you can find symmetries in the middle. So that would be symmetric, but that does not mean that these other two pieces are symmetric. In fact, they're probably not. They could be. You could have an x to the fourth that did this. So in this case, do we have a maximum? Well, we could put a maximum would be infinity, but this would be considered a relative max. Do we have a minimum? Yes, and a relative min. So if it asked for minimum, that would be it. But if that went down like that, you would need to find the minimum there, and just make sure that you put your left and right bounds close enough that you could do it. And you guys are old enough and advanced enough now. I'll show you what I usually do. Well, sometimes do. So let's look at the first equation. So, well, let's take a look at that first problem. So our equation is x to the third minus 4x. So x to the third, oops. Oh my goodness. X to the third. Well, my calculator messes it up. Okay. So let's oh, that's kind of funny. So it hits right here and right here and right here, and if it goes up, now if you just looked at this, you might say, oh, -1 comma 3 is the max. And even if you check the table, second table, -1 3, okay, that point does exist, but it's not the maximum. So if we push second calc max, well, it's not the relative max. So one way you can cheat, if you are on the answer, left, enter, right, right, enter, left, enter. That's a fast way to find them. So this point is actually -1.15, comma 3.079. That's a relative max. Right, so the actual maximum is infinity, and the actual minimum is negative infinity, or you can say none. I don't care, either one. Well, if you write infinity, you also have to write negative infinity. Or you can say none. Yeah. Okay, so you're not really writing this point anywhere. Okay? Well, over here, this relative minimum is going to be 1.1 or 2, wait, what is it? 1.15 comma 3.07. Now, this doesn't always happen, but can you see how these numbers are the same? It's negative 3.07. That's not always the case. The only reason that's the case is because the roots are the same distance apart. So if I were to move this root over here, what would that do to my relative max? It would move it left, and it would also move it up, right. So if your roots are equal distance apart, then these y values are going to be the same. And the only reason the x values are the same is because it went through 0, 0. Okay, so this is kind of an unusual cubic equation. So domain, what would the domain of this be? All real numbers? Okay, where is this increasing? So from negative infinity to negative 1.15, union with 1.15 to infinity. Okay, where is this decreasing? Negative 1.15 to 1.15. You guys, from here to here, it's going down. So what are the x values for where it's going down? It starts, so from the left side to the right side. Okay, so where is this positive? So how many positive pieces are there? 2. There's this one, and there's this one. So from -3 to 0, union with 3, or no, that's 2, right? -2 to 0, union with 2 to infinity. Well, we need the union to say that it's in one or the other. Okay, and I'm just introducing you to that union thing, which we'll probably run into again later. When there are two intervals that belong to the same answer. So, well, the increasing had a union, and positive had a union, and negative has a union. So negative would be negative infinity to -2, union with 0 to 2. Okay, and this has no max or no min. So you either say it has none, or you say max is infinity and min is negative infinity. Well, hold on. Zeros. -2. Well, I'm going to write plus or minus 2 and 0. Y-intercept 0. If I didn't have it, how would I find it? You can go to the table and look for x equals 0. What's the easiest way? You could do value 0. What's the easiest way? Look at the equation. What's the constant? This one has no constant, so it's 0. Now, that's only true of polynomials. If you had a sine curve or a cosine curve, you can't trust the constant. Okay? Okay? And then end behavior. So there's the end behavior there. As x approaches negative infinity, f of x approaches negative infinity. As x approaches infinity, f of x approaches infinity. So that's saying as we move to the left, the graph goes down. As we move to the right, the graph goes up. Okay? Think you guys can hack that? No? All right. Good luck.